Hello friends and welcome to YouTube channel Freedom Tech, and in this session what we are going to learn. In this session we are going to use YOLO object detection, pre-trained object detection model, and then we will detect petrol pump activity with YOLO and AI. So before we move to our practical friends, if you learned something from our videos, please consider to subscribe our channel. Okay friends, thank you so much and let's get started. So friends, as I mentioned, today we will use YOLO pre-trained object detection model and we will detect petrol pump activity. Simple. So we will basically use YOLO object detection model for counting the person we have right now on particular area in petrol pump side, and then we want to know that the how many vehicles, or let's just say vehicles in the sense the car, how many vehicles enter and how many vehicles exit. Simple. So this is the whole concept. So you will get the project folder, and I have here project folder. You will get the project folder which is the petrol pump activity. Right click and then just click on extract all. It will extract our project folder. The project folder is available on Buy Me a Coffee, where we created a shop. Simple. So you have to simply purchase the project folder, then just click on it, and let me show you first a video file. So if I click on the video file, so as you can see, this is what CCTV footage, and our goal is to count how many persons we have right now in whole area. So of course we have our YOLO object detection model which will detect the person. You can create your own model also as per the requirement. We will use the by default model. You can create your own model to detect, like this person is sitting on the chair. So if we use the by default model, this person will not detect because this person was sitting on the chair, but when he stand up, it will detect by the by default model. So we will use the model and we will detect the person, total person. Simple. And then we have here, as you can see, this is the entrance. This is the entrance. As you can see, the car is coming inside the petrol pump. Let me show you. Okay. So as you can see, the car is entering. So this car is entering inside the petrol pump. So my goal is to what? I want to know that the how many vehicles is basically enter. You can go further, you can simply use generative AI, or you can use like a timestamp for mentioning which car coming at which time. Simple. But we will not go that much further for this tutorial. We will only create how many cars or how many vehicles basically enter and exit. Simple. Also we will count the person using the by default model. Here I will not create any custom object detection model, the by default model. So this is the video file. Now let me explain how we can handle all these things. So with the help of our object detection model, we will detect the person. It is really easy. We will detect the person, and then because we have ultralytics tracker, so each person we will get the unique track ID. Each person we will get unique track ID, and then we will save all this track ID inside the list, and the length of list is basically the number of person we have on particular this side, or let's just say on particular this area. But it is counting person is really easy for this kind of scenario because we have the track ID, and if we send all this track ID inside the list, so length of list is basically the track ID, means length of list is basically how many person do we have, because we have unique track ID, we have ultralytics unique track ID for each person. So each person we have unique track ID. It means it is really easy to count the person. It is really easy. But if I want to know that how many vehicles enter and how many vehicles exit, how we can count that? Because if we want to create a counter, what we always do, we draw the line. Like just say if I want to count the vehicle, so simply I will draw the line either vertically or let's just say either horizontally. But in this scenario the camera angle is look like this way, so we can't draw the line here or here because the entrance is here. Entrance is here. It's not like if I draw the line from here to here and then I can count the car, or let's just say if I draw the line from here to here and I can count the car. I want to draw the line on the frame particular point, like just say this is the start point and this is the end point. So how do we count this start point and this end point using the line, and we create the condition? For that we will create the function. We will create the function which will manage all these things. So this is basically our video file. Now let me open our code. You will get the full code. Simple, you will get the full code. So I will use YOLO 12 s.pt, which is the pre-trained object detection model. This is the video file. Let me first start the code. So for that what we will do, we will simply stop a while loop. I have mentioned 0 over here. Let's just save the code. If I run the code, first it will download our pre-trained object detection model. As you can see, it's now downloading our model. So friends, as I mentioned, as you can see, this is what our scenario. This is what our scenario. It's look like this way when we start our model. When we start YOLO object detection model on the video, it will look like this way. But first, I forgot to mention here, we need our packages. So go to the tools, manage packages. Let me stop the code. Go to the tools, manage packages, and we will search for OpenCV-Python. OpenCV-Python. Select the package, click on install button, done. It will install OpenCV-Python. Then we need here ultralytics package, ultralytics package. Search for ultralytics package, first package, click on install button, then click on upgrade button. It will upgrade the ultralytics package. So let's just wait for upgrade. So we upgrade the ultralytics package. Then we need here CV zone package. So search for CV zone, first package, click on install button, done. It will install CV zone. Now this is how we want to install the packages. We need OpenCV-Python, ultralytics and CV zone. Now let me run the code again. So friends, because we upgraded the ultralytics package, there is a numpy error. As you can see, there is a numpy error. So we need here particular numpy version on Sony Python IDE. So if I stop the code, you can simply download the latest Sony Python IDE using the Chrome browser. You have to simply search for Sony Python IDE and you will get the latest Sony Python IDE. So as I mentioned, we have now basically the numpy error. So inside project folder, I have mentioned important.txt file. If you open that file, so we need this particular numpy version 1.24.4. so just copy it, open Sony, go to the tools, open system shell, and then just paste that line, the code line or package line, and then hit enter. It will install numpy 1.24.4 version for ultralytics. So friends, as you can see, we successfully install our latest package. Ignore all these things, simple. Let's just close it and let's just try to run our code again. If I run the code, as you can see, we successfully run our code. It means there is no error. We need only, after we upgrade Ultralytics package, we need this particular version. I have mentioned the file inside the project folder also. You have to run the command pip install numpy 1.24.4 for running the Ultralytics with the help of Sony Python IDE. So now we detected our object. So as I mentioned, with the help of YOLO, we are detecting here car and person. So I have mentioned here a class. As you can see, the classes is 0, 0 for the person and 2 is for the car. So we are detecting here person and the car class, but right now there is no car. So we are detecting the person. And as I mentioned, because we have Ultralytics powerful tracker, so each person we have here tracker. So this person we have one ID, this person we have two ID. So this is the unique ID for each person. And if I want to create a counter for person, simply we will mention here like this way: if we detected the person from the name. So name is basically the list of our object. So list of object is basically from our model, which is the YOLO12s.pt. From the model.names we will get the class ID. We will get the class ID. So each class ID, simple. So but we want here only 0 and 2 the class ID. So 0 is basically the person. 0 is basically the person. Sorry for friends, I forgot to mention here, we will get here list, not class ID. The names is basically the list, the object list, simple. So this list, now inside these names we have object list, the by default object list. And then here we have here the ID, we have here class ID, we have here class ID. So the name is equal to our names, the list, and inside that we will pass the class ID. So class ID, which we only want here 0 and 2, which is the person and the car. So it will only detect two label, two classes, which is the person and the car. So if we detect that the person, then we will create the list.append, and inside that, as I mentioned, we will append the track ID. Because each person we have unique track ID. It means if I want to track the person, simply I want to save their track ID inside the list, and then this list, here it is, as you can see, this list.append inside this list. Now we have the track ID, and here the length of list, L is equal to the length of the list, length of this list. This list is now the counter for the person. So L is now counter for the person, and I have put the L means the person counter on the frame here. So right now if I skip the frame, as you can see I am skipping the frame, it says there is a 2 person. There is a 2 person means there is a 2 track ID. The true track ID and length of those track ID is now 3, because we have here 1, 2 and 3 person. So this is how we will create the person counter for petrol pump activity. Now the main thing is what? As I mentioned, we have here entrance gate. This is what the entrance gate, and if I want to create the counter, usually we draw the line from here to here horizontally, or let's just say vertically from here to here. So this is what my start point and this is what my end point. This is what my start point and this is what my end point. But in this case the angle is completely different. So the car is basically coming from this side. So how do we count over here? For that we want to draw the line like this way. So simply because we have here c2.event mouse move function, this is the function c2.event mouse move. With the help of this function we will get line start point and line end point. So if I move my cursor over here, the coordinate is basically 150 or 114, or if I go like here, The coordinate is 149, 112. So I have mentioned here 150, 114. If I go over here, the coordinate is 418, 91. 418, 91. So line P2 and P1. Line P2 and line P1. Simple. So line P2 is basically this coordinate 150, 114, and line P1 is basically this coordinate 419, 92. And then with the help of CV2.line method, we will draw the line, and the color is basically the white, thickness is 2. As you can see, now there is a line on the frame. So now friends, we will create a function. So what is the function? Our function is basically the counter. Our function is basically the counter. So counter is equal to px, py, x1, y1, x2 and y2, and it will return x2 minus x1 multiplied by py minus y1 minus y2 minus y1 multiplied by px minus x1. This is what the function, this is the function. And then now what we want here, we want to save detected car or detected vehicle track ID inside the dictionary. So for that, hist is equal to the track ID along with their current position, along with the current position of detected object. So inside this hist, now we have track ID along with the current position, of the object. Simple. And then now we have the track ID inside this hist. So we can create a condition. So what is the condition? For condition, first we need here previous CX and previous CY. Here it is, as you can see, the previous CX and previous CY is equal to hist and the track ID. So for that, the condition is, if the track ID inside our hist, then we will do all these things. Then we will mention the person condition, we are saving the person track ID inside the list and all other things. And then the same way, if the track ID inside our hist dictionary, we will mention over here previous CX and previous CY. If the track ID inside hist, then previous CX and previous CY is basically the hist and the track ID. Now we have current CX, current position, current CY, and then previous CX and previous CY. Now we need here previous side and current side. So previous side is basically our function, which is the counter. Okay, counter. And then inside that we want to mention here previous CX and previous CY, this previous CX and CY. And then we will mention line P1 and line P2. Because line P1 and line P2 we have two coordinates, so we want to mention all as a one. We want to mention two coordinate, the tuple format coordinate as a one. For that we want to mention the line P1 like this way. There is a sign, this sign. Simple. And then we will get the previous side, and same way the current side is equal to, so current sign is basically their current position. So what is the current position? Current position is basically the CX and CY. Simple. So we will mention here CX and CY, again the line P1 and line P2. And then if the previous side multiply by the current side less than 0, and the track ID is not in counted, so we created here counted as a set, as you can see, the counted as a set. So if it means if we count those ID already, so track ID not in counted means those ID which we not already counted, track ID not in counted, then we will create if current side less than 0, direction is equal to in. Direction is basically in, and because we only want to detect here a car, so we will create the condition. if the car in name means our list, this is the list, if the car in name, we will increase the counter and we will change the color, and else direction will be out. If the car in name out, we will increase the out counter. It is really easy. We are saving the track ID along with the current position. This is the main condition. Now inside his dictionary we have track ID and their current position, and then we create a condition for person counting. We create the condition if the person in the name, we are saving all those track ID inside this list dot append. Inside that we are saving the track ID, and then we are done with our person counting. So the length of list is now the counter for the person, So we are now counting here 3 person, as simple as. So we have done with person counter. Now we want to create the counter for the vehicles. So as I mentioned, this is the entrance. We want to draw the line over here. So we have here a co2.event mouse function. With the help of that function, you can draw the line, and then we have basically the counter function. Inside that counter function, we will pass the previous side and the current side. But first, the previous side and the current side, we need previous CX and previous CY. So previous CX and previous CY is basically the dictionary. Inside that we will pass the track ID. Then we will get the previous side using our counter function. So previous side is basically the previous CX and previous CY and line P1 and line P2, and the current side is basically the current CX and current CY, line P1 and P2. And then we create the condition. This is the condition for direction in and out, and then now we will get the counter for vehicle, which basically going inside or going outside, as simple as. You will get all the code if you download the project folder. For that you have to pay only $1. Only $1 you will get the full code. Simple. So now let me show you here what I will do. I will start here a while loop. Let's just run the code. Now we have person counter, but when the vehicles coming inside from this entrance, their object center point touch the line and vehicle in counter will increase. Simple. So let's just wait. Right now, as you can see, the person counter is 2. This person is sitting on the chair, so the by default model will not detect the person sitting on the chair. You can create your own custom object detection model for this kind of activities. Simple. But I think the by default model is really sufficient. Simple. So right now, as you can see, we have here 2 persons. So person 2, now person 1, again we have person 3. As you can see, now we have person 3, person 4 person. Let's just wait for the vehicle enters. So as you can see, the vehicle is coming, entering inside. When the vehicle touch the line, we will increase the counter. Was detected. There is a center point, blue color, touch the line, and we increase the counter. So it means right now there is a 1 vehicle inside this petrol pump along with the 2 person. As I mentioned, friends, this is the by default object detection model from YOLO 12. You can create your own model. You can train your own model also. Simple. So as I mentioned, I have mentioned the full code. I hope you will learn something from this video. We'll meet our next video. Till then, thank you, take care, and bye bye.